Hey everyone, my name is Venelin, and in this video I'm going to show you some of the most useful operations that PyTorch provides to help you work with tensors. So we're going to start with creating some tensors, loading them from pandas or NumPy, some of the most popular operations on creating tensors with some specific values or random numbers. Then I'm going to show you some of the most basic math operators on those, how you can slice, permute, and view some of the tensors. I'm going to show you how you can essentially load and save some data. And I'm going to show you how you can convert between types, different types of tensors, and how you can put your tensors on the GPU in order to do much faster computations. Let's get started. The first thing that I'm going to show you is how to create some tensors. There are two primary ways to do that. One is to create them from some types of arrays, lists, etc. And the other way is to use some other source of data, something like NumPy, pandas, or something like that. So first, let's start with something really simple. Here is the project that we have thus far. It contains the environment already loaded in. And the only thing that I'm going to install is pandas. And this is already installed on this machine. So you should do this on your own. Also, I should take a note that this is actually now running Torch with support for CUDA. This will not be that important for this video, but for the next couple of ones, you might consider installing the CUDA version of Torch. So the first thing is to import the Torch library. And from here, I'm going to create a scalar using the Torch library. So I'm going to use the tensor function, which is just going to accept a single number. And we are going to print this. And as you can see, the output is a tensor of 42 for this one. All right, so what can we do for the list example? Or what happens if you want to have a list and convert it into a tensor? It's pretty simple. You just input a list here, like that, and then you run it, and you get pretty much the list, but it is wrapped in this thing called tensor. So I'm going to continue with creating a matrix tensor. Here. So this is essentially a 2D array, and I'm going to just pass it to the function here. And as you can see, we get an output of this matrix wrapped again in a tensor. You can essentially do this thing in n dimensions. So to show you that, I'm going to include this, and then these are going to be in one dimension. So each of those, and then I'll get 4 and 5. Let's see. Delete this. And I need to wrap everything into another dimension here. So this is a representation of 4-dimensional tensor, something that is not, as you can see, very easy to demonstrate or visualize. But either way, Torch is allowing you to basically create n-dimensional tensors. Yeah, when you do such things, are really interesting, right? So you can think of tensors as containers of data, and most of the time you're going to have some numbers in those. Let's see what happens if we do a string here, hello world. And what happens if we print this? And as you can see, the tensor library that is included into PyTorch is not accepting strings. So yeah, you have to pretty much work with numerical data if you're going to work with tensors in PyTorch. So the next thing that I'm going to show you is how you can use NumPy arrays and put them into Torch, something that you will most probably need in practice. And it is pretty simple actually. Let's create a NumPy array and then pass that to the tensor function. And as you can see, this is pretty magical stuff. It understands that it is inputting a NumPy array, and from there, using the tensor function, you can basically convert that into a tensor. And another possible thing that you might want to do is to use pandas. And if we, yeah, let's delete all of this. If we create a data frame with some numbers in it, and if I print that data frame so far, yeah. So I have a typo here. I'm initializing the data frame from this dictionary. You can see that we have the pandas table, if you will, or a data frame with a single column called numbers and the values 1, 2, 3. So how we can convert this into a PyTorch tensor? As you might guessed it, we are going to use the torch tensor function again, and I'm going to get the numbers column. And if we print this, you can see that again we have a tensor from this. So these are pretty much the ways that you're most probably going to commonly use. But there are some other approaches you can use to create tensors. And most notably, you're going to use those when you're building models. One of the pretty much most common way to create a tensor that has some data in it is to use some small random numbers. So these might be some initial weights or parameters for your models. So I'm going to show you how you can do that. And I'm going to delete the pandas import since we are not going to need it. So how do we create this random tensor or a tensor with random numbers? We are going to call the rand function. And this gets this thing called size. And here I'm going to specify essentially that I want 2 rows and 2 columns with numbers that are random. And we'll see what the random number generator is giving us. So these are the numbers. I think that the numbers specified as such are going to be between 0 and 1. So small random numbers is what you're going to get. And they will be in the dimension right here. If we run this, yeah, you should take somewhat similar but yet different results, since the numbers are close to 0, but between 0 and 1, but of course they should be somewhat random. So this is one way to create tensors using some of the helper functions that Torch is giving you. Another very common or popular approach is to create a tensor of zeros. And PyTorch has a function for this. Again, it accepts size. And if we pass in the same parameters, and run through this, you're going to see that you're given again floating point numbers. What happens? But there are zeros, of course. What happens if I call this once function, which is pretty much the same thing, but for once? As you can see, you are again given floating point numbers. This should be somewhat interesting to you, as we are going to dive a bit deeper into types in a bit. So, okay, we have ones, we have zeros, we have random numbers, and what happens if you want to specify the value that you're going to fill this tensor with? So to do that, I'm going to show you a full function from Torch, and this takes again the size, and then this fill value, which is going to be 42 for us. Run this. And as you can see, we have 2 by 2 of 42 as numbers. So you can fill a tensor with a specific number if you want to. And the final thing that I'm going to show you as a way to create some tensors is to use a range. So what happens if you want to use, for example, a range of values? You don't have to type them one by one, of course. There is this method called aRange, which you can give a value at which this range is going to stop, or more importantly, the number of items that you want. And as you can see, we have 3 items, and since we are starting from 0 for the index, we have 0, 1, and 2. So we've seen how you can create the tensors. Let's continue with checking the types of those tensors. I've told you that some of the times we got integers and some of the times we got some floats in here. So what I'm going to do now is to create a simple tensor. And I'm going to check the type of that tensor. As you can see, we have a tensor with int 64, and if you call this property dtype, you will get that. It is important to note that you can't have something like this. And some of the numbers are going to be integers and the other are going to be floats. That's not possible. Essentially, what is happening under the hood, Torch is converting everything here into a float, and then your tensor is only going to have floating point numbers. So keep in mind that a tensor can have only a single type, not a mix of types. This will be important down the road. And you can essentially specify the type that you have once you are constructing your tensor, and this is happening using torch dot and then the type that you want. So for example, I'm going to specify float 32, and even though I'm passing in an integer as an array, you can see that we are getting float 32. So what happens if I run this and I say that I want int 32 for this array? This should pass, but if I print this, you can see 1, 2, 3, 4. But if I say 4.2 here, then again, this is only converted into an integer and the floating point number is getting removed. So keep in mind this when you are working with tensors, that if you are specifying the type, you might lose some information if you're passing in initially some floating point numbers. So instead of passing in this float 32 here, so this is the result from this. Yeah, these are the floating point numbers. We can call this float tensor constructor of this class. And yeah, we get pretty much the same result as we did before, but using this constructor of the class float tensor. So keep in mind that you can also use this syntax. And next, I'm going to show you again a simple tensor, but we are going to call this property called device. And this maps to CPU. So even though this tensor is not stored on the CPU, this is essentially given that we are using the CPU memory or the RAM of the machine that you're running the Torch implementation on and the whole program. But another way to store the tensors is to pass in the device that you want, and you can essentially do this thing when you specify the device and you say CUDA. So this is only working if you have the proper software installed for the CUDA, and then you have the PyTorch version that is proper for this, and you have a GPU or video card that is allowing you to run this. I have 1070, which is pretty old, but it looks like that it still runs with the current version that PyTorch supports. And if I run this, you're going to see that we are running this tensor on the GPU. So when I run this program, this tensor is going to be moved to the GPU memory, and then tensor can work there. This is very important because PyTorch is utilizing your GPU or GPUs when with some small amounts of code you can train much faster your models. So this will be very important down the road. Keep in mind that there is a way to specify the device that you want, but there are some even smarter approaches when you're talking about training on the GPU or the CPU, etc. And I'm going to dive a bit deeper into those later in the course. So the final thing that I'm going to show you in this section is that if we start with a tensor that has, let's say, int32 as a type, let's check it from here, and then we can essentially do this, get it, and then I'm going to say tensor.float, run this, and as you can see, even though I'm starting with an int32 tensor, then I can convert it essentially using this float method to a float tensor. So this will be very important again when you're training your models and building your datasets. So keep in mind that there is this method, and then we can pretty much do the same thing for the device thing. If I call .2 and I say CUDA and check the device again. So first we are on the CPU, and then if I run this, you can see that this same tensor has been moved to the GPU. So you can use conversion between types, and you can use conversion by taking, essentially moving actually your tensors from the CPU or the RAM to CUDA using this to method, and then your tensors are going to be running on the GPU. Some of the most common operations that you're going to do with PyTorch tensors are basic arithmetic operations, and Torch is happily for us providing everything that you might need or desire. So I'm going to show you how you can, for example, do some addition. And this is pretty simple actually. X plus Y should give you the result of this. And as you can see, you're given essentially column by column addition. Then for the subtraction part, pretty much the same thing. Yeah, we have -2 and -2. So you can see that PyTorch is overloading the Python operators, and it is making it much easier to work with those. For multiplication, pretty much the same thing. And as you can imagine, we have the same thing for the division. So everything should work as expected. Next, I'm going to show you how you can do comparisons or masking. So I'm going to call this variable mask, and I'm going to ask for all values that are strictly larger than 1. And I'm given this mask, which is essentially specifying for each element in this array, or this tensor more specifically, what values, how are values comparing to this expression. So as you can see, 1 is not larger than 1, but all of the other elements are. So this works by giving us this. And then I'm going to use the same mask to take only the elements that are true in this condition. And as you can see, you can use this mask to just take 2 and 3 in this case, which are the elements that are essentially correct or true for this condition. So this is pretty cool, and you're most probably going to use this in practice. So I'm going to show you the next thing, which is going to be matrix multiplication. And I'm going to build some simple matrix here for x and y. And to do matrix multiplication, we are going to use this operator, which is again an overload. And as you can see, we have matrix multiplication given this operator here. Pretty straightforward and very fast implementation by PyTorch. You can also do element-wise multiplication for those matrices. And as you can see, you're given the element-wise multiplication of the elements. Pretty much very straightforward. You can also create some vectors. And you can use dot product to run through this. And as you can see, you're given a dot product of these two vectors. So pretty straightforward again. And sometimes you will use this, especially if you're building your own models, which we are going to do. Next, I'm going to show you how you can take the sum of a tensor values. You can probably guess by now how this might happen. There is a sum method on the tensor. And yeah, this is the sum, which is again, keep in mind that PyTorch is returning tensors, even though if you're calling sum here. So this is pretty straightforward implementation, and it's easy to understand, but most of the time, most of the operations are going to be not returning just numbers. They're going to return numbers that are wrapped in those tensors. So keep that in mind. You can take the maximum value of a tensor with max and then the min one. All right. So keep in mind another important thing, that if I do this, and I have a matrix. So what min is going to return? Is going to return 1. But if I specify this, yeah, this is going to return something a bit different. So since I'm specifying another dimension, not the 0th one, this is going to essentially take this list or vector and then this vector, since this is a matrix, and I'm specifying that I want the last dimension, which is 1. And keep in mind that if I specify -1, yeah, the result is going to be the same. So when we are working with dim as a parameter, you can specify -1 or -2, etc., etc. And -1 is corresponding to the last one, no matter how many dimensions you have. Keep this in mind, this is a shorthand or a shortcut that is very useful. So when I specify this from the first vector and then the second vector, or for each individual row in our matrix that we're doing, PyTorch is going to get and go and take the minimum values of these rows. And as you can see, in the first row it's 1, and then in the second row is 4, and it is giving us the indices in another tensor, if you're interested in that. And this dim or dimension parameter is pretty much applicable to every operation that you're working with when you're working with PyTorch. So keep in mind, I'm not going to dive a bit more deeper in it right now, but it is very useful to know about this parameter. And yeah, the next thing that I'm going to show you is how you can get the index of the, for example, maximum value. This is argmax. And in this case, this should return 2, since 3 is the largest element, and the index of it is 2. And again, it is giving us a tensor. So these are pretty much very important operations on tensors. One of the final things is going to be checking for equality. And yeah, I'm going to show you this. You might think that it is straightforward, but it has some gotchas in here, which you should be aware of. And what happens if I specify if x is equal to y? This should work in regular Python, but it appears that is giving us this array of booleans, which is something that we don't want. Let's create a z, and if I specify this, this is returning 3 true. So what is essentially doing is comparing first element to first element, second element to second element, third to third, which is something that I'm currently not interested in, to get whether or not one tensor is equal to another. You should call equal method, the equal method. And as you can see, this is returning a single boolean. And if I do this for the y, it should return false. So this is how you're checking for equality of the whole tensor. Keep this in mind, it's very important, especially when you're comparing for some metrics or calculating accuracies. Next very important operation is the clip operation. Let's say that we have this tensor, and we want the minimum and the maximum values to be of some specific values. And I can specify this thing called clip, and I want the minimum value to be 2 and the maximum value to be 8. So if I run this, even though I'm passing in 1, 5, and 10, since 2 is larger than this is going to be, and this is the minimum value, this is going to become 2, and 5 is alright since it is within this range. And for 10, we have 8 here, So 10 is larger than 8. So this gets clipped down to 8. Very important when we are building our neural networks. This is a very common hack in order to clip the gradients of your neural networks. And this command is working in there under the hood for you. But I'm not going to go I'm not going to go a lot deeper into that, at least not until we do some trainings of neural networks and other models. So the final thing that I'm going to show you with the probably most commonly used operations on tensors is this where. Let's say that we have this as a tensor. And when I apply where, what we are going to do is if the number here is larger than 2, so 3, 4, and 5, nothing is going to happen. Otherwise, I'm going to set the values to -1. And if I print the result of this, you see that since 1 and 2 are not larger than 2, these values get replaced with this, but the other ones stay the same as the original input. So this is very important when you are trying to replace some value within your tensors based on condition. Alright, so another thing that is very commonly used is slicing and indexing of your tensors. So let's say that we have this tensor. You can essentially get, for example, the second element by using the first index, very similar to what you have in arrays or lists in Python. So this is pretty common. And you can use slicing that is very similar to the lists in Python. So this should take only the first two elements of this tensor, which is correct, as you can see. Then if you want to skip the first two elements, you can use this syntax. And then if you want to get the first and second element, so 2 and 3, you can use this syntax. So this is the index that you want to start from. So this is the first index, which is corresponding to 2. And then you want to specify the index that is one larger than the index that you want to get. So in this case, this is going to be 3. And in this case, you're taking just 2 elements. So this is very neat way to specify a subset of the data or the tensors that you're working with. Another very useful approach is to just specify the indices that you want in an array. This is pretty much similar to the mask thing that we did. And this should go ahead and take 1 and the last element, which is 5 from the tensors. One very important concept about the tensors that you're working with is called the shape of the tensor. And I'm going to show you that for this tensor, if I call this property called shape, which is very similar to what you get in NumPy, if you're familiar with that, you take that you have one-dimensional list with 6 elements. So you can essentially always check the shape of your tensors using this very amazing debugging tool, if you will. And of course, you can do something with those dimensions. You can essentially massage them. And for example, you can create a matrix out of this tensor using the reshape function or method. And in here, I'm going to specify that I want 2 rows and 3 columns. And if I pass in the matrix shape, you see that we have this. And if I print the matrix itself, you're going to see that this list or vector has now been converted into a matrix. Very useful. Next, I'm going to show you that you can essentially transpose the matrix using .t, which is a large T, which is again an operation that is doing a transpose of the matrix, and it works quite well, as you can see. Another way that you can use those shapes is to call this method permute, which essentially you can tell the order of the dimensions that you want to permute them in. And I'm going to do transposition here, but using the permute. And this should give us exactly the same result, as you can see, in two different ways. So one very important operation is the concatenation of tensors. And if I have this tensor, 1, 2, 3, four, 5, 6, all right, so we have these two tensors, and if I call on those torch get, and I pass in a list of those tensors, you see that we have a tensor that is actually a vector of these numbers. And if I want to create a matrix from those, I can use torch.stack. So this will essentially put them one on top of each other and build a matrix for us from these vectors. The final operations that I'm going to show you are how to save and load a tensor or the data from a tensor. So let's say that we have this. And to save this data, I'm going to call this save function. And I'm going to specify the name of the file and run this. And if I go here, and you can see that we have this file called mytensor.t, which is exactly the file that I'm working with. I'm going to remove it and then resave it from here. But then I'm going to load it. And then I'm going to print the loaded tensor values. All right, so it's 1, 2, 3. Under the hood, this is using Pico in order to serialize and deserialize the data in the tensors. And this is pretty much the default approach when you're trying to save your model data or parameters weights using PyTorch. So these are some of the most useful operations that you can do with tensors in PyTorch. Based on my day-to-day work, you can pretty much guarantee that you will use those, and you will have to do some manipulation on tensors, some data, work with some reshaping, probably checking shapes, saving and loading the data. So pretty much very useful operations in order to train and develop deep learning applications. Thanks for watching, guys. Please like, share and subscribe, and I'll see you in the next one.